In example 8, we're solving functions. So we're given the function h of p equals p squared plus 2p. And we want to solve for h of p equals 3. So in this scenario, okay, what they're telling us is that they've given us the output. So 3 represents the output, and what we're looking for is the value of p according to this question. So what we're going to do is, we know that h of p equals 3. So what that means is you have h of p is ap there. So that's h of p, right? And then we know that it equals p squared plus 2p. And hp also equals 3. So we're going to set these two equal to each other. So we have p squared plus 2p, which is equal to 3. And what that allows us to do is to be able to solve for p, because now this entire equation is in terms of p, and you can isolate p. So in step 3, in order for us to solve, since we have p squared plus 2p, we can use the zero product rule and subtract 3 to both sides and set this up as a quadratic equation set equal to 0. And then we're going to factor. So recall that when we factor here, we have the value of -3, and the middle number is 2. And so what two numbers can you multiply to get -3? Then when you add them together, it's going to give you a +2. Well, we have a +3 and a -1. And so that's how we're getting p plus 3 times p minus 1 equals 0. And then we're going to set them both equal to 0. So we have p plus 3 equals 0, or p minus 1 equals 0. Subtracting 3 to both sides tells us that p is equal to -3. Adding one side tells us that p is equal to 1. Now this gives us two solutions. So the output h of p equals 3 when the input is either p is equal to 1 or p is equal to -3. And we can also verify by graphing, as in figure number 5. Okay, so what it's saying here is that we have a value, an output of 3. So if you take a look at the green here, okay, the output is on the y-axis. So that's where 3 is. Okay, and then it crosses, okay, the inputs. There's two inputs. One of the inputs is at -3, and the other one is at +1. And so that's just verifying on our graph what that represents.